Hello everyone, welcome back to our lecture series of ring theory. We were discussing ring homomorphism and isomorphism. In this lecture, we are going to discuss some significant properties of ring homomorphism और इन सभी properties को हम एक theorem की form में पढ़ने वाले हैं. इन सभी statements को समझते हुए we are going to prove each and every statement which are defining the properties of ring homomorphism. So let us start this lecture by writing the statement of that theorem, and we are having the first theorem as 15.1. So we are having theorem 15.1, and this theorem is exactly about properties of ring homomorphisms. So we are going to have that let phi be a ring homomorphism from a ring R to a ring S. Okay, then we are having a subring. Let A be a subring of R, and let B be an ideal of S. Then we are having the following statements. I will write the statement first and then prove the statement side by side. So we are having the first statement that for any R belongs to the ring R and any positive integer n, we are having this one that phi of n time r is same as n time phi of r, and phi of r to the power n is same as phi r to the power n. So we are having first this property of ring homomorphism. तो सबसे पहले हम समझते हैं ये प्रॉपर्टीज का, इन प्रॉपर्टी का मीनिंग क्या है. So here we are identifying the phi image of addition of r n time, right? Here n time r represent the addition of r n times, and this is same as the n time addition of its phi image, right? जैसे अगर हम 2r लिखें यहाँ पर तो phi of 2r that is phi of r plus r, right? And that is same as twice of its phi image. And the same thing is here we are having the multiplication, and r to the power n represent the multiplication of r by itself by n times, right? And this is same as the n copies of phi image of r. Okay, so let us try to prove this, and then we will come to the next statement. Proof. I'm starting the proof so that we can use this one for the further proof of these statements as well. So we are given with the homomorphism, right? So given that phi defined from R to S is a ring homomorphism, right? We are given with this, where R and S are rings, right? ये हमें given है. Then what about phi of nr? Then first, if we talk about this one, then phi of nr, that is same as phi of addition of r n times. So we are having r plus and so on plus r. This is n time, right? Now if we apply the homomorphism virtue, then we are having phi of r plus phi of r plus and so on plus phi of r. ये हम क्यों लिख पा रहे हैं? क्योंकि phi एक homomorphism है and this is same is n time phi of r. Okay, so this is simple one and the next one is also similar. वहाँ पर बस operation multiplication है. Now we have phi of r to the power n is same as phi r r r and so on r, and this is again n times, right? And by using the homomorphism concept we can write this as phi of r and so on phi of r, and obviously this is n time multiplication of phi r with itself, so we are having phi r to the power n. So this is how, and hence the statement. Okay, this is how we can prove the statement, hence the statement. Now come to the next one. So we are having the second statement as phi of the set A, where A was given as subring, that is equals to phi of A such that A belongs to A is a subring of S, right? So let us try to prove this. अब यहाँ पर हमें given था that A is a subring of R, right? So given that A is a subring of R, ठीक है? And what about phi A? Phi A is defined as phi of A, where this A is coming from the subring A, ठीक है? Obviously अगर phi R to S में एक मैपिंग है तो phi of A, ये जो भी सेट बनेगा that will be a subset of S. ओके, अब हमें कोई भी सेट है उसे रिंग कैसे प्रूव कर सकते हैं या फिर सबरिंग कैसे प्रूव कर सकते हैं? वी नो वी कैन यूज द सबरिंग टेस्ट. ओके, सो नाउ वी use the subring test. Okay, for this let, now we need to choose any element from this one, so we are writing that let phi of x and phi of y are from phi of A, where this x and y are element of A, where A is subring, right? So what we can say, सबरिंग के लिए हमें बस ये बताना है कि ये डिफरेंस के लिए क्लोज्ड है और मल्टीप्लिकेशन के लिए भी क्लोज्ड है. सो फ्रॉम द फर्स्ट वन वी नीड टू राइट दैट व्हाट अबाउट phi of x minus phi of y. So we have taken two arbitrary element from this given set phi of A. अब हम इसका डिफरेंस लेंगे और मल्टीप्लिकेशन लेंगे. फ्रॉम द डेफिनेशन वी कैन राइट दिस एज phi of x and plus phi of minus y, right? And this is equals to phi of x minus y. Now look at the scenario. यहाँ पर x और y दोनों ही A सबरिंग के एलिमेंट है, तो x minus y भी सबरिंग A का ही एलिमेंट होगा, और जब x minus y सबरिंग A का एलिमेंट है तो इसकी phi में phi of A का एलिमेंट बनेगी. So this is an element of phi of A as x minus y is an element of A. ठीक है, अगर x minus y A का एलिमेंट है तो इसकी phi इमेज phi of A से बिलोंग करेगी. So we are having that phi of x minus phi of y is an element of phi of A. Then we are having the second one, that is phi of x time phi of y, which is equals to phi of x y. ये क्यों लिख पा रहे हैं? हमने कहा है कि phi is a homomorphism. ओके, अगेन क्योंकि x और y दोनों ही एक एलिमेंट है तो phi of x y भी phi of A का एलिमेंट बनेगा. So this implies phi दिस इज सेइंग दैट phi of xy is an element of phi of a. कैसे लिख सकते हैं? A is xy is an element of a, right? So thus phi of a is a subring of ring S, okay, because phi of a was subset of A. अब इस स्टेटमेंट में हमने क्या देखा? वी हैव प्रूव्ड दिस स्टेटमेंट, और इसका सेंस क्या है कि अगर फाई कोई रिंग होमोमॉर्फिज्म है और ए कोई रिंग है तो इसकी फाई इमेज भी एक रिंग ही बनती है, ठीक है? सो व्हाट वी कैन राइट दैट रिंग होमोमॉर्फिक, और लेट मी राइट homomorphic image of a ring is a ring, ठीक है? जब भी हम किसी भी रिंग की होमोमॉर्फिक इमेज आइडेंटिफाई करेंगे तो वापस में रिंग ही बनेगी, ठीक है? कैसे? जैसे कि अगर R रिंग है तो फाई ऑफ आर, दिस विल इम्प्लाइज दैट फाई ऑफ आर ये भी एक रिंग बनेगा, ठीक है? सो वेयर फाई इज रिंग होमोमॉर्फिज्म, तो आर रिंग है तो फाई ऑफ आर भी एक रिंग है, दैट इज दिस स्टेटमेंट वांट टू से।